Hello and welcome to this AQA Further Statistics video, Discrete Random Variables 3, the last in the series looking at critical values and critical regions. In the last video we looked at this example where we modelled the number of faulty light bulbs produced per hour with a Poisson distribution where lambda is 4.5, and we carried out a test at the 5% significance level. So for consistency we'll still use a 5% significance level, and we looked at an observed value of faulty light bulbs in an hour and came to a decision about whether to accept or reject the null hypothesis lambda equals 4.5. In this video we're looking at a different approach where, rather than having an observed value and using that as a test statistic, we're going to be deciding at the beginning of this what extreme small or large values we need to observe in an hour for us to conclude that the mean has changed. And these critical values, because it's a two-tailed test, can occur at the very low end, and certainly the probability of getting 0 looks quite small, or they can occur at the high end, and we need to obtain some Poisson probabilities, cumulative probabilities, to work out where our critical values are, where our cut-off points for making the decision to reject the null hypothesis lie. And because we are doing this test at the 5% level, we are going to be looking at how many values do we need to be including. So the probability of obtaining those values is 2.5% or less when our null hypothesis is telling us that lambda equals 4.5. And what we need to look at is where our cutoff point is. So the probability of getting up to one value is below 2.5%, and the probability of getting up to the next value along, so if we look at the lower end it would be 0 and 0 and 1, is greater than 2.5%. And if we look on GeoGebra, you can obtain the individual probabilities, and you can see the probability of getting 0 is just over 1%. The probability of getting 1 is actually 5%. So the probability of getting 1 cannot be in our extreme tail because the probability will be way over 2.5%. Alternatively, you can look on the calculator. So this is using the cumulative distribution, and you can see the probability of getting 0 and 1 is 6%. That's too big. So our critical value at the low end is 0. And you can just check that again on the calculator. Probability of getting 0 is just 1%. So in order to keep our tail end occurring with a probability of below 2.5%, the only critical value we have in our critical region is simply 0. At the top end we perhaps are slightly uncertain, so you would probably want to work out the probability of getting 9 or more, 10 or more, 11 or more, and find out when the probability is greater than 2.5% and when it's less than 2.5%. And I think you can see from here the probability of getting exactly 9 is pretty close to 2.5%. Once we start to add in 10, 11, 12, all of those other extreme probabilities, that's going to take us over 2.5%. So our critical value actually is 10. The probability of getting 10 or more is 0.017, and that's below the 2.5% we need. So for our upper tail, our critical value is 10 and our critical region is 10 upwards. And that means that we can make a very simple statement that we are going to reject the null hypothesis if the number of faulty light bulbs observed in an hour is either 0 or is 10 or more. 0 and 10 are those critical values, and 0 or below, well that's only 0, and 10 or above are our critical regions. And the critical region we can write like that, or you can write it in set notation. And you may see this being used in a question, so it's worth familiarizing yourself with it. But the simple message we would give to somebody is, if you find 0 or 10 or more, let me know, because we're going to reject the null hypothesis and think something's gone wrong and there is a change in that value that we thought was the value for lambda. If we now look at the actual significance level, with a discrete distribution, getting to exactly the nominal significance level, in this case 5%, is impossible because of the nature of discrete variables. And so in this case our lower tail has a probability of just over 1%, our upper tail 1.7%. And so the probability we reject H0 is the sum of those two, which is a 0.0282. And so our effective level of significance, because we cannot get it to exactly 5%, is 2.82. And 2.82% is less than 5%, but the closest we can get. And do remember that we can't decide to split that 5% unevenly. We must be fair, and each tail must have a probability of 2.5% or less to give us the critical regions or the critical values that we're going to use. So it's probably worthwhile pausing for a moment here and just reading through this example and think, what's the important information here, what hypothesis and alternative hypothesis are involved, what the significance level is, and how you would actually proceed to find the upper and lower critical values and to state the significance level. So hopefully you identified the fact that x, our random variable, the number of bubbles per square meter, is modelled with the Poisson distribution, and under the null hypothesis that is 5.7, and our alternative hypothesis is the mean is not equal to 5.7. Our significance level is 10%, so we are looking at 5% or less for the probability in the lower tail, 5% or less for the probability in the upper tail. And just very quickly, and you can use your calculator to verify this, you should find the probability of getting less than or equal to 1 is 0.0224. If we include 2, that's too large, it takes us over 5%. So our critical value is 1 and our critical region is 0 and 1. And if we look at the top end, again, this is probably easier to do on the calculator. The probability of getting 10 or more, probability of getting exactly 10 is 0.0334, and by the time you add in all the more extreme outcomes that we must include, that comes to over 5%. So our critical region is actually 11 or more. The probability of getting 11 or more is 0.0314, which is less than the 5% probability we need for that extreme tail. And so our critical values are 1 and 11. Our critical region, our region where we would reject, would be 0 and 1 or 11 and more. And the actual level of significance is the sum of the probabilities for each tail for each critical region, and that's the less than or equal to 1, the 0 and the 1, or the 11 or more, and if we add those up we get 0.0538, so our effective significance level is 5.38%. And that concludes this series of videos.